Hello friends, it's Ben again. This is a video for the differential calculus class. We are looking at a section, the number of which escapes my mind, but the title of the section has something to do with graphing. So one thing to notice with this is that the way I was trained to graph stuff is super duper old fashioned. And so I, and maybe your textbook author would do a lot of things that you don't really need to do. So what I'm trying to do is to make things not eat up your time. I'm trying to suggest that you do as much with technology as you can, but if you can't, that's hard, okay? You have got to make a guess there. When is it appropriate and when is it not? I would make the suggestion, judge your effort level. If it didn't take you any effort, if all you had to do was read something off a screen, I probably wanted you to do more. Okay, so anyway, that's the guideline there. I am going to want you to draw your pictures using Desmos or some other graphing program. When you do that, don't half-ass it, okay? When you draw something, figure out where is appropriate for ranges and stuff. If you graph it and there's like nothing interesting showing on the screen, probably something is off about where you've set your parameters to graph in your viewing window. It's really up to you to experiment around and figure out some of these things. So, sorry. I know that's maybe asking a lot, but let's see what we can do. All right, sharing screen with you real quick here so that we can get a general listing thing in front of you. 1, 2, 3, go. Yay. All right, so when you're graphing, I will frequently say to you and label anything that's important. And I am so mean, I don't tell you what that means. There's lots of things that could be important about a graph, but they might not be. If you look at a graph and it does not hit the x-axis or the y-axis, it doesn't have an intercept, you know? So, you know, this can get confusing. But this is just a general listing of the type of things that you might run into and some super quick guidelines about trying to figure out what to do. So if you're trying to figure out intercepts, that's where something hits the x or y intercept. Try that again, the x or y axis. So what you do is to either set x equal to 0 and solve for y, or set y equal to 0 and solve for x, okay? And go ahead and list both coordinates of the point, just to show me that you know what it is that's going on. Then for maximums and minimums, you are totally going to be able to just see them on the graph if you got a good graphing program. But I'm asking you to do exact values. So if you set f prime of x equal to 0, and, you know, say the f prime of x turned out to be x squared minus 2, you set that equal to 0 and solve, and you get x plus or minus radical 2, leave it as x plus or minus square root of 2. Whereas if you looked at it on the graph and just copied it off, you'd get 1.41. And I can tell the difference, you know, and I am asking you to get a little bit of sophistication there of learning to set things equal to 0 and solve, okay? The other thing is finding the second derivative and setting that equal to 0 and solving, okay? So then if you've got a vertical asymptote appearing, you'll be able to see, because, you know, there's some big spike in the graph or something. And so you usually have a denominator, or maybe you might have a logarithm, okay? But if it's a fraction with a denominator that you can set equal to 0 and solve, do that. If it's a logarithm, set the stuff inside the log equal to 0, and solve for that. Horizontal asymptotes are always limits as x is going to either infinity or minus infinity. So take the limit and check to make sure that you're getting the right thing. Okay. Then the occasionally seen slant asymptote usually comes from a rational function where it's a polynomial divided by another polynomial. And the thing to do is to do long division on the polynomials, and whatever terms happen to be going to 0 as you go off to infinity, go ahead and ignore those. The thing that's left is going to be the slant asymptote. Okay. All right. So this is going to seem a little bit sparse, but I'm just going to work through this one example here that's got lots and lots of different things in it. And then I'm going to ask y'all for several different examples that don't have as many individual things for them to try to see what's going on. Okay, so we are going to get a sketch of this, and then we are going to try to label anything that's important. Okay, with regard to labeling, we're going to try to get exact values. If we can't, we're just going to admit that we can't. So, say something about that. All right. So I have purposely not tried to figure out some of this stuff ahead of time. So, for example, I do not know how to do the screenshot portion here, but I think we can figure it out. So that function we had, oh man, I already forgot what it was. It was this 2x squared minus 1 times the e to the minus x squared. So 2x squared minus 1 parentheses e to the power minus x squared. All right. So immediately there you can see the picture. You get a pretty good idea of what it looks like. But before we try to do anything else, let me show you. I am grabbing the y-axis and smushing it and stretching it. Okay. So if I were to instead grab it diagonally, it would increase and decrease the axes at the same rate. If I do the x-axis alone, I can do that, right? So I'm going to mess with this a little bit. I can see just visually here, immediately I can see that I've got asymptotic behavior that we're going to y equals 0. Now I might go ahead and expand it out a little bit and try to see, because it could be that I have something tricky where I've got asymptotic behavior, but it's going to a number that's just close to 0 instead of actually equal to 0. But all right, now I've got this here, and I am going to touch the graph, and it immediately put gray dots on a whole bunch of important things. One thing it did was down here, at 0, -1 is a local minimum, and it also happens to be my y-intercept. My x-intercepts here, I get labels like that. I think I know what that value is, but we're going to try to figure it out exactly in a minute anyway. So then these up here, you know what? I don't know. Those values there look like approximations, and I do not recognize them. There ought to be a point of inflection shown here, but I can't seem to get Desmos to do that. And it's because we're dealing with a function that's kind of complicated. But y'all can see how it's kind of cupped up here, and it's kind of cupped down here. Yeah, come on. Cups down here. So somewhere along in here, we're ending up with a change in concavity. Likewise here, it is cupped up, and here it's cupped down. I suspect that the intercepts may turn out to actually be the points of inflection. I don't know that for sure, but it kind of looks like it might be. It's pretty flat there though. So if I do that, is there any way? No, I still can't really tell. But do notice that when I messed with it, it immediately took away all of my labels. So if you're wanting to be able to label something, you have to figure out when to label it as in comparison to taking your pictures. All right, so I'm gonna explore around up here. In my upper right-hand corner, I have this kind of a share thing where it says share your graph, and it says share this link. So that's just links. It's not going to give me the option to download the picture. Now, if I were on the website doing this, the picture is one of the options there. Side note, I went ahead and signed up for a free account on Desmos, and that allows me to save all of my graphs, and that's pretty sweet. So, well, maybe it might not matter for y'all, but for me, I'm probably going to end up using this same example next semester, so I gotta be able to access it. All right, do I have anything else in these menus? Oh, it's going to take everything out, no matter what I do. All right, sliders, tables, restrictions, tutorials. Nope. I can put it in, wow, some of the scripts are really pretty. So can I do anything here with pictures? Nope. And so I have depleted my options. All right, I'm gonna go ahead and do that one thing. Oh no, I'm going to, since I'm on an iPad, say, hey Siri. Hey Siri, how do I take a snapshot on an iPad?
Okay, I found this on the web for how do I take a snapshot on an iPad. Check it out.
Okay. All right, so it sounds like it should be easy to do. And how to take a screenshot. So you stumbled onto the pictures, blah, blah, blah. Screenshots, come on. It's going to give me like several pages of ads. Locate the home and top or power buttons. All right, so I know where those are. I should have known how to do this. All right, so the home and power buttons at the same time. All right, so it took a picture and it will have saved that to photos, I believe. All right.
I didn't get that. Could you try again?
No, I can't, Siri. Thanks. Could you go home? Go away, Siri. Bye. Okay. So I'm going to jump. Oops, I jumped to the wrong thing. Don't need that anymore. I'm going to come in here. And so I've got a picture button. You have a picture button as well on your Jamboard. And you ought to be able to access photos from it. If you can't, you may have to get a little bit more inventive with it. So, all right, so that shows the picture in there. And if you want to make it bigger, you can make it bigger. But just, oh wow, and it showed Siri trying to talk to me. Great. All right, then I'm going to go through and try to find some of these things. So intercepts, y'all can see on there that we have 0, -1, and this plus or minus 0.707. So the thing I'm going to do is to do my my y-intercept by setting the x equal to 0. So going back to the original function, the x being equal to 0 says that the y is going to be equal to, you'll have the 2x squared minus 1 e to the minus x squared, so e to the 0, so that's minus 1. So that says that the point is 0 minus 1. And that is, in fact, this point down here. So then the other ones, the x-intercept, we'll set the y to 0. And so we have 0 equals 2x squared minus 1 e to the minus x squared. Now, Exponentials cannot be equal to 0, so we don't have to worry about that. And we can just go ahead and cross that one out. So that has to be the 2x squared minus 1 is equal to 0. So that says that 2x squared needs to be 1, which says x squared needs to be 1/2, which says that the x needs to be plus or minus 1 over root 2. So the points are plus or minus 1 over root 2, comma, 0. Okay? And if we look back here, if you were to whip out a calculator, that 1 over root 2 is about 0.707. Okay. So the next thing we're going to look at is these maximums and minimums. One of them we already know what it is, but these others we want to get exact values if we can. So we're going to go to the function there and find f prime of x. So it is 2x squared minus 1 times e to the minus x squared. So that means we'll have to use a product rule, and we'll have 4x e to the minus x squared plus the 2x squared minus 1. Any exponential, when you take its derivative, you get back the same thing, but then you have to multiply by the derivative of the thing that was in the exponent. Now, if you factor the e to the minus x squared out there, you are left with 4x minus 4x squared plus 2x. Okay. And you can see that we are going to get some x's that we can pull out there. And so I'm going to go ahead and say that is 2x e to the minus x squared at, I did it again, I did not leave enough room. Let me just grab all this stuff and shove it over there. So 2x e to the minus x squared, and then the 4x and the 2x had given us a 6x before we took out the 2, and then minus the 4x squared would be left with a 2x there, right? When you set this equal to 0, then you're going to get x equals 0 from that, and you're going to get, I copied something wrong here, folks. Apologies. This here was supposed to be an x cubed, wasn't it? Because, and the way that I knew that is kind of a cheating thing. I knew that because I knew I was supposed to get 2 answers here. If you look back here, I can see there's a positive and a negative maximum. And so then I go ahead and do that. And you can see that you'll have to get x squared is equal to 3/2, or x equals plus or minus the square root of 3/2. Okay. And then we ought to go ahead and plug those back in and see what's going on, but I'm not going to. I'm just going to go ahead and label that we know this one's a minimum from the graph, and that was 0 minus 1. And we know that these ones here are both maximums from the graph. Okay. All right, and I'm going to put a little divider line here so you can see where the work stopped. And I'm going to do it again because I might be a little bit OCD and I want my line to be straight if I can make it straight. All right. So now we're going to have to look for inflection points. So for inflection points, we are going to need to know a derivative. And so I am going to go ahead and copy this function that we have here. And on the next page, write down that f prime of x was this thing here. And so now I need to figure out f double prime. So I need to take the derivative of that. Yuck. but it is a product, so I can use a product rule. So I'm going to take the derivative of 2x and get just 2, leave the e to the minus x squared alone, leave the 3 minus 2x squared alone, plus. Now I'll leave the 2x alone. Derivative of e to the minus x squared is e to the minus x squared times a minus 2x. Leave the 3 minus 2x squared alone. And then plus, now we'll leave the 2x alone, and we'll leave the e to the minus x squared alone, and we'll take the derivative of 3 minus 2x squared and have minus 4x. So notice that out of every one of those, we can get a 2, and we can also get an e to the minus x squared. So that leaves a 3 minus 2x squared, okay, and then a, this one here is a little bit hairy. It's got the x, we get the 2 out, but we'll get another minus 2x, so we have a minus 2x squared being multiplied by the 3, so minus 6x squared, and then multiplying the minus 2x squared times another minus 2x squared is plus 4x to the fourth, yay. And then finally, this one here, after you took that 2 out, you'll be left with a minus 4x squared. Now that looks pretty yucky. It also looks like we don't have room to do asymptotes on the same page, so I'm going to put them off for now. So the thing that you got to spot is that we have something of quadratic form. Okay, so when we set this equal to 0, because we have x squared and x squared squared, that means that we can go ahead and solve for the x squared here by using the quadratic formula. So minus b plus or minus the square root b squared minus 4 times the a and the c, okay, divided by 2 times the a. So that top is 12 plus or minus the square root. 144 minus 48 is 96. And out of 96, I can factor a 16. So that is 12 plus or minus 4 square roots of 6. And that simplifies a little bit as being 3 plus or minus square root of 6 all divided by 2. That's, yeah, so, and that was too low on the screen, so I'm going to erase it and write it where you can read it. So 3 plus or minus the square root of 6 over 2. And those are going to be our inflection points. Right? Now, last bit, I'll add a page on here. And now we're going to look for asymptotes. So you can clearly see there are no vertical asymptotes. If you look at the graph, you can spot that, but you can also look at the function and see that nowhere in it are we dividing by 0. So we don't have to worry about that. So for a horizontal asymptote, we're going to take a limit as x goes to infinity of that thing. It had 2x squared minus 1, and down here it had e to the minus x squared. Okay. Oh, sorry. When you put it down below, you take away the minus, don't you? All right, so it should have been e to the x squared sitting in the denominator. All right, so if we take that limit and try it out, we can immediately see that we end up with infinity over infinity. So that means we'll use L'Hopital's rule and we'll get the top to turn into just 4x. And the bottom is going to be an e to the x squared and then times 2x because of the fact that you have to use the chain rule, right? And that means that we can cancel those x's. And for that matter, we can cancel the 2 against the 4. And now as x is going to infinity, we've got 2 over infinity, so we end up with 0. So y equals 0 is our horizontal asymptote. Okay? And that gets all the important pieces, right? We had spotted here these intercepts, and now we've got the inflection points. It turned out the inflection points were not equal to plus or minus 1 over the square root of 2, like I thought they would be. We can get to numeric approximation if we need it. Okay, but the asymptotes that we could see here and max and min, yeah. So we've got all the important things that appear on that, and that gives us an idea how to tackle these things. First, go get a graph. Okay. Once you've got a graph of it, you can spot where the max and min and so forth are, and you may not be able to get the exact values. But when you can't get the exact values, turn to the calculus, figure out where f prime or f double prime is equal to 0, figure out where your limits as things are going to infinity, things like that. It's all totally stuff you've done before. It's just throwing it all together at once and having instructions that are a little bit vague. So sorry about that part. All right, I will see you all in class. Weirdly, I hope you will have had a good weekend by the time you see this. So I'm going to go have mine now.